Hi. Hey guys. Thank you very much for coming to our talk, Common Security Mistakes in Python 2022. In this talk, we're going to talk about how to hopefully write more secure software. We are going to talk about the process to achieve that in the past and in current days. And we are also going to show you some common security mistakes. Oh, thank you. Thanks, Gil. That we see all the time, and also their mitigations. Let me introduce myself. My name is Eyal. I'm the head of security research and a founding member at SCI. And what my team do is to discover and implement new hacking activities as part of our flagship product, Hiver. And now I'm going to pass the mic on to my colleague, Gil.
Thanks, Eyal. My name is Gil, and I'm the head of application security and SDLC at SCI. SDLC stands for Software Development Lifecycle, also Security Development Lifecycle. And the second meaning is my title. And I'm a hacker for roughly 17 years. My specialty is in application security and also pen test, secure development, assessment trainings. And this presentation is actually a shorter version of a full course that we do at SCI for developers. And I'm part of the services department at SCI. We perform penetration tests, red teaming operation, forensics, secure architecture, and many other premium services, cybersecurity services. So before we start and dive into the live demos, let's talk about the high level, security in agile development. So in a perfect world, your code, the intended functionality, and the actual functionality would be exactly the same. But we do not live in a perfect world, and the intended functionality is not the same as the actual functionality. The things that you've successfully built, these are the build features, and you have bugs, which are things that you wanted to build and you haven't successfully done so, and you also have unintended, undocumented functionalities, such as an admin interface that you left open by mistake, or a debug flag that you left enabled. And the goal of security development lifecycle is to minimize security-related vulnerabilities in the design, code, and documentation, both vulnerabilities related to bugs and to undocumented functionalities, and to eliminate it as early as possible. Why? Because the earlier you detect it, the less you have to pay to fix it. You can roughly divide vulnerabilities into two types. One is implementation errors, and one is design issues. Design issues can be found before you write a single line of code. Before you start your first line in Python, you can already detect it and secure your design of the system. So the goal is to detect it as early as possible, and it is made of best practices, processes, standards, security activities, and tools. And it is an ongoing process, like the software development lifecycle itself. And for each step in the software development lifecycle, you have corresponding steps of security. And there are several methodologies and frameworks that are common for security development lifecycle. You have one of OWASP that I'm going to mention later on. You have Microsoft SDL, which was the most common one, the first and the most common one. SDL, again, stands for Security Development Lifecycle. And Microsoft, the original SDL, was very detailed. And for each step in the software development lifecycle, you have a corresponding step for security. For example, when you define your requirements, you have security requirements. When you define your design, when you design your system, you have design requirements and review. When you start writing your code, implementation, you can use approved tools, and you can also use manual and automated code reviews, which were originally defined as optional activities, but they are de facto mandatory nowadays. When you start the verification step, QA, you have also automatic analyzers and penetration tests. This is our specialty at SCI. Again, it was originally defined as an optional activity. Now it is de facto mandatory. And when you release your application, you have incident response plan and other final security reviews. So this is Microsoft SDL in a nutshell. And there isn't one through. You have different organizations with different resources, amount of resources that can be invested in security. If you are a small startup, for example, you can settle with a basic code review, penetration test, and basic awareness training. If you are a medium organization, you need all of the above, plus integrated security expert in-house. integrated security tools, and for formation of development procedures, secure development procedures. If you are a large organization such as the bank, you need a dedicated security team that thinks about security all day long and integrate in-house tools such as, and also in-house security operations center. This is a center that monitors all of the systems 24/7. So this is an example of different types of organization that invest different amount of resources into cybersecurity. And in the past, everything was simple because we used waterfall style development. Waterfall is an obsolete method of developing where you release a version every once in a while, every few months. And you have a lot of time to invest in cybersecurity because you don't have a lot of time to do each and every step. Implementation can take months. And this is how we used to develop 15 years ago, 20 years ago. But then came agile development. And this is what everyone knows today. So there are cross-functional self-organizing teams. There are short time box development iterations or sprints. You deliver small functional story. You do not release a huge version with tons of functionality. And there's no extensive upfront design because it keeps evolving. And as a result, you cannot take the traditional security development lifecycle methodologies and implement it with Agile. You cannot complete all the activities in one sprint. The requirements and architecture evolves over time. If you have some basic threat model documentation, it becomes outdated very quickly because the system keeps changing. If you have sensitive third-party connections, you might not initially know them. And your team doesn't include in-house application specialists because they are smaller teams. So Microsoft took their traditional SDL and modified it to Agile, to the Agile world. And they defined 3 types of categories: every sprint requirement, bucket requirement, and one-time requirements. So every sprint requirement is so essential to security that no software should ever be released without these requirements being met. For example, run automated SAST tools. SAST stands for Static Application Security Testing. These are tools that scan your code and find vulnerabilities in your code. And SCA, Software Composition Analysis. These are tools that scan your libraries, your dependencies, and find known vulnerabilities in other people's code. For example, outdated Django or outdated Python library of some kind. And another example, update the threat model. If you do have one, then you can update it on a sprint basis. Bucket requirement, a team prioritizes the pool of tasks over main sprints. You can imagine multiple tasks that shouldn't be executed in each and every sprint. And you have a bucket that can be either divided according to submodules or topics. And for each sprint, you select one task from each bucket and execute it. And each task must be completed at least every 6 months just to make sure there isn't starvation. And for example, you can run DAST. DAST is Dynamic Application Security Testing. This is a tool that scans your running code. For example, if it's a web server, a web API, and you deploy it and you scan this API. And there are other design review tasks, etc. One-time requirements tasks, these are generally once per project tasks that won't need to be repeated after they're done. For example, configure your bug tracking system, usually it's Jira, and you need, for example, to clearly label security-related issues. So you'll be able to see it very quickly. Identify in-house and external security or privacy experts. We are our client's security expert, external one, baseline threat model, etc. So basically, you have to make sure that every sprint requirements have been completed. No one-time requirements or bucket requirements exceeded the deadline. At least one requirement from each bucket category has been completed, and no security or privacy bug are open that exceed the severity threshold. Usually, critical vulnerabilities need to be mitigated right away. If it's a high severity vulnerability, you need to mitigate it at the current sprint. If it's a medium one, you can set an SLA of 1 month, for example. So this is some requirements of severity threshold, for example. Each organization with its own nuances. So this sums up the high-level security development lifecycle methodology, and now let's dive into the actual examples. What happens when you do not follow the best practices that I just showed you. So the system that we are going to show the demos on is a typical shopping website. You have the users that connect through the internet to a web server, and you have a database. Very typical architecture, very simple one. And if you think about security development lifecycle, as I mentioned, you can start thinking about the threats and design issues even before you write a single line of code. And this is an example of a threat modeling or threat analysis. An attacker steals the identity of a user in the system. This is a critical severity threat. An attacker steals users and password information, also critical. Number 5, an attacker defaces the website. Defacement is an attack that changes the look of a homepage. This is a high severity threat. Number 7, attacker attacks the site customers. This is a medium threat. And number 9, attacker is able to see technical and operation information. This is low. So before I start to write my first Python code, my first row in Python, you can also start thinking about security. And for example, for number 2, I can encrypt and hash my credentials and then lower the risk of stolen credentials. And all of the demos that me and Eyal are going to show you are part of OWASP Top 10. OWASP stands for Open Web Application Security Project. This is a non-profit organization that promotes application security worldwide. And every once in a while, they publish their top 10 hottest topics in application security. And this is the latest one. It was published last year. So at number 1, you see broken access control, any attack that enables you to bypass the permissions mechanism. I'm going to show you a demo. It goes under this category. Cryptographic failures, stolen credit cards and credentials. This is at number 2. Injections, SQL injection, cross-site scripting. We're going to see an example. This is at number 3. Insecure design, designers, including malicious file upload. This is at number 4. Security misconfiguration, default credentials, for example, or clear text credentials in configuration files. This is at number 5. Number 6, vulnerable and outdated components, libraries in Python or your web server or even your reverse proxy. Identification and authentication failures, these are vulnerabilities that enables me to bypass the authentication mechanism, such as password cracking. Software and data integrity, lack of input validation, this is at number 8. Security logging and monitoring, this is at number 9. And number 10, server-side request forgery, this is a specific attack. For some reason, it's at number 10. So let's start with the first demo. In the first demo, we are going to show you how to steal data and also edit. I'm able to edit other users' data using a very simple attack called parameter tampering. This is number 1 at OWASP Top 10, a broken access control. It enables me to bypass the authorization scheme and to perform privilege escalation. If you think about the data in the application, usually it risks the confidentiality of the data. Sometimes also other variations enable me to compromise the integrity and availability. And it is an applicative vulnerability that can only be fully mitigated by code fixing. Even if you have a firewall and an antivirus and a web application firewall, which is specifically designed to tackle applicative vulnerabilities, nothing would stop this attack from taking place because there is no signature. I'm taking one valid value and I'm replacing it with another one, as I'm going to show. So in the first demo, user A accesses his own data, user B accesses his own data, but user B can also access user A's data. So let's see it live. So here you can see, this is my shop, nice name, and you can see that my user, I'm already logged into my user, which is 1, 2, 3, 4, 5, 6. And if I go to my account, you can see that my user ID is number 4. So what can I try and do? Change it. Very simple. And now, if I see my email address here, and I change this from 4 to 5, suddenly I see another user's email address, and then I can harvest email addresses of clients that use this shop. It's a very simple vulnerability. You do not need any hacking utilities. And the vulnerability source is lack of authorization verification. My code doesn't check the permissions of the currently logged in user. And this is a mock-up code. You can see here my details, and you get the ID from the URL, and you immediately send it to the data access layer without checking the permissions of the currently logged in user. And unlike other vulnerabilities, this vulnerability, the framework is not going to help you. We are going to show you SQL injection and cross-site scripting later, and the advanced frameworks can help you mitigate the other vulnerabilities, but nothing would help you with this one. This is your responsibility. And you probably think, yes, but Gil, this is stupid. No one does it. But this is a very simple example of the most common vulnerability we see nowadays. Really, this is the most common one. If you have an API, it's not always that simple, just modifying the URL. It's a parameter as part of the URL. Sometimes it's a hidden request that you do not actually see, but we use proxy utilities that actually intercept. We are able to intercept and modify any value that your API receives. And then we do exactly the same. Maybe it won't be as easy, but it would be exactly the same, and we see it all the time. So if you have an application with with an API in it, most chances that you are also vulnerable to the same vulnerability. Another very similar looking attack is called forceful browsing. In this attack, instead of modifying the parameter value itself, you modify the URL. And so instead of going to the regular interface, I can, for example, guess that there is a directory called /admin/login, and suddenly I guess there is I access a Django administrative interface. And this may lead to full hijack of an admin account. It's far more severe than hacking into the regular interface. Another very common vulnerability is SQL injection. This is number 3 in our top 10, a part of injections. It used to be number 1 for many years. I'm been practicing SQL injection for 17 years. We see it less than we used to because advanced frameworks eliminate it, but we still see it from time to time. And later on, we are going to show you examples of how to make sure that your code is not also vulnerable. The definition of SQL injection, this is a code injection technique that exploits a security vulnerability in the database level of an application, such as queries. Basically, I'm modifying the way the SQL query works. It risks confidentiality. In some cases, it can also risk integrity and availability, and also lead to full remote code execution over your server, fully taking over your server. And if you want to fully mitigate SQL injection, you need to secure your code. So if you have a web application firewall, it might make me work harder, but eventually, most chances I would be able to bypass it. So let's see the very basic example of SQL injection. Imagine you have the login screen, web form, you enter your username and password, and it is being translated into this SQL statement. Select star, give me all of the columns from the users table, where username equal my user and password equal my pass. Basically, I'm telling the database, dear database, go to the users table and find me a single row where the username value is my user and password value is my pass. And if this is correct, if this is a correct combination of credentials, I'll get this row back and the system will let me in. If this is not the right combination, it won't match any row in the users table, and I'll get no rows from this query, and I'll see an appropriate message saying incorrect username or bad password. So this is normal operation of any web form authentication. What happens in SQL injection? Instead of putting just a plain username and password, I put in SQL syntax that enables me to modify the way in which this SQL statement works. So take a look at what's happening here. Select star, give me all of the columns from the users table where username equal my user and password equals empty string. This can never happen. Or 1 equal 1. And because we are in a Python conference and not in JavaScript conference, 1 always equals 1, unlike JavaScript that you have different types. And this is SQL also. So basically, all of the rows are returned from this query. And I'm assigned with the first user. It has nothing to do with the value I put in the username field. I can put a non-existing username as well. So this is the classic SQL injection example. What should have happened if this was not vulnerable to SQL injection? I would put the exact same thing from the hacker's perspective, but at the database level, there would be a slight change that would make all the difference. Select star, give me all of the columns from users, where username equal my user and password equals, apostrophe, apostrophe, apostrophe. This is not a quote. This is 3 times the character apostrophe. So basically, if you want to put an apostrophe value inside a string in SQL, you need to encode it. And the way to encode it is to duplicate it. So I'm actually searching for the password value apostrophe or 1 equal 1 minus minus. And if this is not the right combination, I get no rows and I'll see the appropriate message. So you probably think, okay, so in my Python code, I can just duplicate any apostrophe and no more SQL injection, right? This is what I see that developers do from time to time, but this is a bad practice. Later on, Eyal is going to show you the best practices for eliminating SQL injection in Python. So in the next demo, the hacker can steal the first user's identity, or there are other techniques that enables him to steal the identity of other users as well. Let's see it live again. So here, if I go to user number 2, the regular interface, login interface is not vulnerable, but if I go to user number 2, you can see that I see the admin panel, the admin my account panel, and suddenly I have here secret configuration file interface. Very interesting, suspicious. If I put just any value, I'll see that I'm not allowed. But if I put another variation of the same payload I just showed you, instead of 1 equal 1 minus minus, I'll just use this. So I'm closing the developer string, and he is closing my string in favor. If I take this, and I put it in both the username and the password, if one of these fields is vulnerable, I would be immediately let in. And now you can see that I see the secret configuration file. So how can you detect SQL injection? If you want a quick and dirty test that you can do for your own system, just put an apostrophe everywhere and look for errors. Because if you've put one apostrophe, as you can see here, select star from products where product equals, you have a beginning of a string, an end of a string, and what's the last apostrophe for? It's redundant, so your database would shout at you, unclose quotation mark after character string, for example. So just put apostrophe everywhere and look for errors. This is the quick and dirty way. This is how it looks like in Python, Python with MySQL specifically. The more professional way, this is what we do, we use operators. So for example, I can divide the string, the input string, into 2 strings, and then reconcatenate them using plus, a string concatenation operator. So if I put a apostrophe plus apostrophe a, and it is being treated the same as AA, I know that someone took the 2 parts and reconcatenated together. Same goes for numeric parameters. If I put 3 minus 1 and it is being treated as the same way as the number 2, I know that someone calculated it. And this usually, this is a database engine, and I can also usually detect the database type, which is important for later steps. From the defender's point of view, you can have code reviews, and we are going to see an example of vulnerable code. And penetration tests, this is what we do at SAI. And you have automated tools, scanning tools, and also detection tools, etc. So this is an example of vulnerable code. There are 2 main reasons. One is lack of input validation. Maybe I don't want to allow non-alphanumerical characters at the username field. And 2 is string concatenation. When you build your SQL query, don't build it like this, using string formats. You can see here, I'm concatenating the user input directly into the SQL statement. This is a bad practice, and whenever you have an internal code review, when you review one of your team members' pull requests, if you see this, then raise the alarm. This is vulnerable to SQL injection. Another thing that hackers do is use union clause. A union clause is basically takes 2 select statements and combine them together. And the hacker's goal is to inject a union clause and a second select statement that gets the data that he wants. For example, credit cards or credentials. And this harms system confidentiality. And this is how it looks like. Select product name and product description from product where product name equals chair. If you enter chair, you get all chairs. A very simple product search engine. But instead of just plain chair, I put apostrophe, union select, table name, and a dummy value from L tables, and suddenly I'm getting all the tables from the database. And then I can select which table I find interesting and query for its columns, for example, accounts, and select the data from it, and then steal it. So the next demo is advanced SQL injection. It is number 3 in OWASP top 10 and also number 2. And you might think this is not common nowadays, but I also show you recent examples from Django. So in the next demo, let's see how can I steal credentials or credit cards from the database. So here in our shop, you have a search mechanism. And for example, I can search for the word watch and get watches. If I put here a single apostrophe, you can see an error. Again, this is a big telltale sign. And if you take this advanced, I'm fast forwarding. This is a huge fast forward. In the full course, I'm teaching all of the different steps. But if you take, you do a fast forward and you take this union select statement from credit cards, you can see that I'm getting credit cards instead of products. Some examples from the news. Heartland is a payment company provider that works with MasterCard and Visa, and it was the largest data breach ever. It still is the largest credit card leak ever, when 130 million credit cards were compromised 12 years ago. They were fined with $250 million for MasterCard and Visa, almost $2 per card. Sony was also struck 11 years ago with SQL injection. Luckily for them, it was not 130 million, only 77 million. And I don't know if there are students in here, but universities are common targets. Don't do it. Don't do it. I don't want this on my conscience. It's illegal. But also it happens from time to time. And here are some examples, recent examples. 2022, just 2 months ago, a SQL injection was discovered in Django in the latest major version. So it still is very relevant. And even the framework itself can be vulnerable. Here is another example of Django. Here specifically you can see aggregate and extra methods were vulnerable to SQL injection, and these are pretty common. And unfortunately in Israel we have license plates with numbers only, but imagine what if you have this license plate and you go to highway number 6, or you have a speeding camera taking your photo. Who knows? Let me pass the microphone to Eyal for the next demo, cross-site scripting.
Thank you, Gil. The next demo we are going to show you is how to mislead the user. We are going to attack the user instead of the server, and we are going to do this with a vulnerability called cross-site scripting. Cross-site scripting, or XSS, is very similar to SQL injection. It's also an injection type vulnerability, but instead of attacking the server, we actually attack the user. An XSS happens when attacker-controlled data is mixed with HTML, and then the attacker can control the HTML and the JavaScript that the user sees. So the attack looks like this. It's a little bit more complicated, but still pretty common. So what the attacker has to do is to trick the user into visiting a malicious link. The link contains the attacker-controlled data. When the user visits the link, he goes to the server, gets back the HTML from the server, but this HTML contains malicious JavaScript that sends the data back to the attacker. Another possibility is to have the script redirect to a malicious site to do very convincing phishing attacks. Again, a very, very common attack. Yeah, let's do the demo. So what we are going to do is to use the search engine again. You can see that when we search for a product, we see the product name watch reflected back to us. We can see it inside HTML. So the next thing to do is to see if we can inject valid HTML into the answer, into the response. So let's try to do a line break, like a BR tag. And when we search for it, we can see that the page now contains a line break, which means that HTML is interpreted. So now let's try to inject a script. Let's do like the idiomatic script test for XSS. Now we should see an alert pop up. Okay, so we can inject arbitrary script into the session of the user. So now we are going to do like a demonstration of how to do a complete defacement of the malicious link, just to demonstrate that it's possible. So when we search for this malicious data, what happens is the entire page is replaced with our content. And of course, this can also be like a login page that actually takes the data and gives it back the password to the attacker. So one important thing, right now we attack ourselves. We want to attack somebody else. So since the data is contained inside the URL, all the attacker has to do is to give the URL to a victim and have him click on the link while the user is logged into the website. So just as a demonstration, we can open this in another tab and it still happens. Okay, but we are all here like technical people, and you can say, okay, why the hell would I click on a link that looks so suspicious? Right, so I guess like nobody would click on the first link, but like we can encode the link and make it look less suspicious. Let's see that. Oh, sorry, mine. Yeah, so the second link look a little bit less suspicious. We can encode the entire data, and now like there's no way to detect it with your own eyes. Right, so it still contains the same data, just URL encoded. You don't even have to use the less than and greater than brackets in some cases, because sometimes the data is reflected back inside an attribute. For example, it's very common to have the data reflected back to the source of an image. If I'm inside an attribute, all I have to do is break out of the attribute using double quotes, and then open another attribute, like an event, and have my malicious script live inside the event. It's the exact same attack. It's very hard to detect. The source of the vulnerability is twofold. First of all, lacking input validation, meaning like if you don't need to accept all characters, then just don't. We will talk about this later. But also the root cause is lack of output encoding. If you want to take data and show it inside HTML, you have to do the proper HTML sanitation or encoding. In frameworks like Django or Jinja, it usually happens due to the developers choosing to disable the automatic encoding mechanism. So in Django, you have the filter that's called, ironically, safe, which makes the entire template unsafe. Safe meaning that the data was checked by the developer to be safe beforehand. If you want to do it manually, you have to replace like special HTML characters with their appropriate representation. Yeah, so let's do another example. This time we are going to use an attack called persistent XSS. It's like reflected XSS, but it's more dangerous because the malicious data is stored in the database instead of in the link. It makes defacement attacks much more severe, for example. So what happens in persistent XSS is that the attacker puts the data inside the database, for example, leaving a review on a product. It lays a trap. When users visit the trap, the comment, they get back the HTML with the malicious data. And again, the data is interpreted as code, sends the user data to the attacker, or do defacement, or redirects the user to a malicious website, or whatever. It's like complete account takeover. Yeah, let's do the second demo. It's very similar to the first one. The payload is pretty much the same. But instead of putting the payload in the link, we're going to put it inside the review. So let's search for a watch. Gil, let's search for a watch that you don't like so much. Let's give it a very, very bad review.
Which one? Rolex.
Yeah, Rolex.
I don't like Rolex.
Yeah. Rolex is too expensive. Let's give it a 1-star review. Yeah. Exactly my thought. And let's put almost the exact same payload. In there, actually the exact same payload, and now it's living like a trap in the database. Every time a user watches the review is interpreted as HTML and deface the website. So now it's like complete attack, website takeover, and it's really hard to detect. There's no attack signature in the URL, and somebody have to go to the database and manually remove the review to do it. You can imagine it's pretty difficult to analyze what's going on without looking at the database. So example for cross-site scripting attacks. First of all, security products like Fortinet, for example, can also be vulnerable to vulnerabilities. Usually in websites that are vulnerable to XSS tend to be clients of like rich type of data, like email clients or SharePoint or Facebook. Facebook was riddled with XSS vulnerabilities in the last few years. Also, there are libraries that from time to time are vulnerable to XSS. In Python, there's like Django was some function in Django was vulnerable to XSS. Also, like the Python ecosystem in general, one library was vulnerable to XSS. We don't want to dunk on Django. We like Django. Flask, the Flask ecosystem can also be vulnerable. The Flask admin package was vulnerable to XSS. Like so, cross-site scripting in the admin interface is much worse than in the main website, like just any other vulnerability. Okay, so now let's talk about mitigation. Let's talk about how to fix the issues you saw so far. Okay, so preventing SQL injection in Python. So the Python ecosystem actually is very mature in the sense that it has lots of ORMs. If you use an ORM like SQL Alchemy or Django ORM, you can use functions to build your SQL query instead of using like raw strings. If you use functions, then the framework would build the SQL query correctly for you, so there's no problem there. But from time to time, you have to like handwrite your own SQL query. Especially in very big and complicated systems, sometimes you need to do that, and you should know what to do in this case. So instead of taking the parameters and like using a format string to put them directly inside the SQL query, or trying to encode the data by hand, what you should do is use the Python DB API. There are drivers for all the major databases, and what you have to do is to put your parameters inside the parameters parameter. Right, and then the framework knows how to encode the data according to the syntax of the specific database driver. Yeah, one more thing that's important to do, it's like an extra defense layer, is to use hardening. If your website doesn't need read or write access to a certain table, then don't give the website this access, right? Use the least privilege you need in order for the website to function. Okay, let's talk about how to fix parameter tampering. This is more tricky. Frameworks can only give you so far. Frameworks can give you like a good design to work with, but ultimately it's on the developer to make sure that every sensitive view, every dangerous action is checking for the correct permissions. What you can do as a developer is to try to design your code so it's easier to review. For example, put all the functions in like a centralized business logic layer, so you only have to review that. Input validation. So input validation is another important defense layer to defend your code. So if your input is an email, maybe you only want to handle valid emails, only strings that are valid emails, and don't handle the rest of the strings. If you want only alphanumeric characters, like of certain length, you can use the built-in regex library to do that. Every major framework has regex filtering mechanism, so you should use that. If you use only alphanumeric inputs, then most XSS and SQL injection vulnerabilities will be gone. One important thing to remember is to use whitelist filtering mechanisms and not blacklist. So for example, you think maybe that if you deny the attacker from using like the less than and greater than brackets, then you're not vulnerable to cross-site scripting. But as you saw before, this is not always the case. And even if you need the brackets to exploit the vulnerability, sometimes if you have like UTF-7 encoding or US ASCII encoding in your website, or if it supports that, you can sometimes bypass the blacklist this way. Yeah, so if you want to use HTML encoding to prevent XSS, as you should, so usually most frameworks like Django template and Jinja have that built in. If you want to do it manually for some reason, then Django has a built-in HTML escape function. Even if you use frameworks like Django, or even if you have like a front-end framework like Angular or React in place, developers can bypass the built-in defense if they want to. So in Angular, there's the trust as HTML function. In React, you have the helpfully named dangerously set inner HTML function. And in Django, there's the very unhelpfully named filter safe. So when you're doing a code review, if you see one of these functions in the PR, you should really check very carefully that the developer did the appropriate security tests himself or even challenged the need for these dangerous functions. Speaking about dangerous functions in Python, there are some functions that are very dangerous by themselves. I think you know some of them. Like they are dangerous in the sense that if attacker controlled data reaches these functions, it usually means arbitrary code execution on the server. So let's take the pickle library as an example. Pickle is the built-in mechanism in Python to do serialization. But if arbitrary strings from the attacker reach the pickle loads function, it usually means arbitrary code and command execution on the server. So in this case, just use something else like JSON or protobuf or message back. Yeah, two last things. It's very, very important to keep your dependencies up to date. You can use features like dependabot in GitHub because, as you saw, vulnerabilities could exist in your framework and your libraries, not only in your own code. And one last thing is to try to implement and use automated scanning inside your CI/CD pipeline. It could protect you from having trivial security vulnerabilities reach your production. Now I'm going to pass the mic back to Gil.
So me and Eyal showed you a list of vulnerabilities that we find in our everyday work. SQL injection, cross-site scripting, we find it from time to time. But what we do at SAI is to put it on a graph and to show the real impact, the business impact that these vulnerabilities pose. Instead of just saying you have a CVE in there, outdated library here, or a cross-site script in there, we put it on a graph, and on the left you can see different types of attackers, internet or compromised employee. On the right you see the business assets of the organization, such as business continuity, safety, or reputation, and then we can map the different vulnerabilities that enables someone to execute an attacker. And we have also data scientist guys that calculates the likelihood of each vulnerability. And then we can select the most critical attack route. And we can say, first, focus this route and do not fix the critical vulnerability. Start with this one. This is less critical, but if you fix it, it would be it makes more sense because it would be quicker to fix and it would break the attack chain. And then you can move on to the next vulnerability and the next attack route, etc. And this is what makes us unique at SAI. Instead of giving a shopping list of vulnerabilities and come back to it when you finish, we are the CISO's best friend. We help CISOs to take better informed decisions based on quantifying the risk. So we have different departments. We have the pen test, red team in architecture review, forensics and secure coding, the services department, which I'm part of. We have the R&D department, the cyber security automation that Eyal is part of. You have data scientists that support the smart mitigation plans, and it all comes together into a single platform that we develop at SAI. So in conclusion, application-related security vulnerabilities are generated in bugs in the application level, and the severity is increased due to other levels. For example, operating system or database misconfiguration or unhardened system. You need to mitigate it at all levels, but eventually you need to secure your code. This is why I do this presentation, and I also do a full course. Secure coding and configuration is everyone's work. Developer, DevOps, DBA, team leader, sysadmin, architects, QA personnel. Avoiding implementation of security measures may result in severe security breaches. Even in 2022, we still see these vulnerabilities on a daily basis. Questions? So the question was, are we also practicing or finding legal issues that can arise from using a certain library? This is a whole different field that is unrelated to security. So the short answer is no, but there are some automatic tools, some of them that we use that can help you with it. Yes. The question was, is cross-site scripting a front-end issue? And template issue. So no, there are different types of cross-site scripting. Some of it originate from the backend, from the backend server. The Python code needs, for example, to encode the value before it returns it to the client side. If you use legacy system, In other cases, if you use modern technologies such as Angular, React, or Django template engine, the front end automatically does it for you. But it depends on which technology stack you use. Yes?
That's another question. You mentioned Django and Flask as API engines. What about Fast API? Is it safer or is it not?
So it depends if you use Fast API as like an API engine or as a full stack engine. If you use Fast API to return HTML responses for some reason, which is less common in Fast API, then you also have to check for cross-site scripting vulnerabilities. Yeah.
Thank you very much.
Thank you, guys.